Okay, simplifying rational expressions. When simplifying rational expressions, we want to find common factors. Okay? We want to find common factors in the numerator and the denominator. Factors must be factors. They got to be factors of the entire numerator and denominator for them to cancel out. Not just a factor to terms in the numerator and denominator. Okay? So it's just going to be important that we realize what is a factor and what's not. Remember, factors are separated by multiplication. So just quickly here, just as a quick review, if we prime factor things like 24 and 27, 24 is 3 times 8, right? So we can factor it like that. 3 times 2 times 2 times 2, and 27 is 3 cubed, or 3 times 3 times 3. And if we look here, our common factors are these 3's. Nothing else is common. We can cancel those out, and we're left with 2 times 2 times 2, which is 8 over 9. Again, just going back to simplifying basic fractions, if we prime factor 20, we get 2 times 2 times 5, and 12 is 2 times 2 times 3. And maybe you can do that in your head, but seeing this, I think, helps understand what we're doing here. When we get to the more difficult examples, here we have 2 2's that are common, and the top and the bottom. So this can be reduced to the improper fraction 5/3. Okay? Alright. Moving down here, we're going to do basically the same thing with these rational expressions. We can say, look, 3x, that is already prime. But 12, x cubed, you could say is 2 times 2 times 3, that's 12, times x times x times x. Now this isn't the most efficient way of doing this, but nevertheless, you can see that you have these common factors. And in the end, if everything cancels out on either the top or the bottom, we're left with a factor of 1 over 2 times 2 times x is 4x squared. Okay? And that's our final answer on that one. Now, it gets a little more difficult here as we put more difficult rational expressions in, but here, let's look at how we can factor the top. We can factor a 2 out of each of those terms. So we get 2 times the quantity x plus 4 over 6 times the quantity x plus 4. And so immediately here you should notice that this entire expression x plus 4 is separated from the numerator and the denominator by multiplication. So those will cancel, and we're left with 2 over 6, which I think most of you understand is 2 over 2 times 3. Those would cancel, and we would be left with 1 over 3. So that whole expression reduces to 1 over 3. Okay? One thing we want to note as we go here, we do want to make just a note in our answer, and I'm going to go back to this, our first example with the rational expressions, that here x could not equal 0. If x equals 0, we would have a 0 over 0 case, or a 1 over 0 case, if you look at the final answer. So often when you're dealing with rational expressions, you want to make a little note at the end that that is a solution that it would give you a non-real answer, or is just not possible. We'll give you a 0 in the denominator. In the second example here, we wanted to say that x could not equal -4 in that case. Okay? Last one, most difficult one in simplifying here, we need to look at what we can factor out. So if we begin factoring just the numerator, we can take out a 2 and an x, okay, and that will leave us with x squared minus 1. And in the bottom here, here's a quadratic that can be factored to x plus 1 and x plus 2. Now, we should recognize that x squared minus 1 is the difference of squares, so we'll need to factor that. And if we write that all out, now we can look at our common factors. Now, really in this case, there are only one pair of common factors here. It's the x plus 1 factor, okay? And if we cancel those out, we're left with 2x times x minus 1 times quantity x minus 1 all over x plus 2. Now, a common error would be to look at these 2's here and say, ooh, can I cancel those? But you can't. You can't cancel those. Here's why. 2, although 2 is a factor in the numerator here, this is a factor. It's separated from everything by multiplication. In the bottom here, this 2 is separated by addition, so it cannot be canceled out. So we're forced to say that this is our final answer. Now, some teachers or some books will want you to multiply this out, so if we needed to do that, we get 2x squared minus 2x all over x plus 2, and that would be our final answer. And we want to make a note here in our final answer that x in this case cannot equal, if you go all the way back to the beginning where we factored it here, x cannot equal -1 or -2.